Okay, so if I'm given something like this is how I would use scientific notation. Right? I take something like, maybe create another box over here somewhere. I'll show you how to do this. I'm going to rewrite this. That's going to turn into, here's what you do. Left, where do negative numbers go on the number line? Left or right? Like if you're looking at our number line, which direction do the negative numbers get bigger and bigger and bigger? Elizabeth? All right, so if you see a negative exponent on scientific notation, take your decimal spot and move it to the left, oops, 2 spots. And then fill in the bumps with zeros. That's what that is. 0.015. Okay? Hopefully you won't be confused by the end of the whole table. Then it'll kind of make sense, hopefully. Okay? Now you're going to keep doing this. Instead of, for the next one, instead of moving 2 decimal spots, how many are you going to move this time? Just 1. 1 to the which direction, left or right? It's negative, so you got to go left, right? So you take your decimal spot and you count 1 left. Oops. 1 left. So you get 0.15. Okay, 1.5 times 10 to the 0. 0 means I ain't moving left or right. The decimal's staying in its spot. So this is 1.5. Okay, and if you see a positive number, positive numbers go towards the right on the number line. So you're going to say, okay, grab the decimal, move it 1 spot to the right. 15. Okay, with the table's nice because I think we're going to get the idea. Every time you move the decimal spot, you're going to get 1 extra 0. So the next one, this would be 150. Because if I took 1.5 and moved the decimal spot 2 to the right, 1, 2. 150. And 1500. And 15,000. I'll do the last one so we can see. 1.5. 1, 2, 3, 4. Put your decimal, fill in the bumps with zeros. 15,000. That's scientific notation. Takes big or small numbers and makes them manageable or able so you can type them in your calculator. Okay? Because you don't want to have to type in, you know, this in your calculator all the time. Because I guarantee, and I'm sure it happened to me at some point along the way, when you have 1, 2, 3, 4, 5, 6, 7 zeros, and you're trying to type 7 zeros in your calculator, I'm sure it's very easy to only type 6 instead of 7. Or scientific notation just takes care of that for you. You don't have to think about that. Okay, does anybody have any questions on that so far? All right, so let's try a couple of these, and then I'll let you try. How about I'll do 2, and then I'll do 2, okay? And then I'll let you work on your own, and then we'll take them up, and then I have 2 sheets for you to try before the end of the day, okay? So you can see how this is related to exponents because it's got times 10 to the exponent, okay? Okay, so for this one, I think one of the other key steps is identifying where the decimal place actually is. So with A, where's the decimal on this one? Declan?
It would be 1.25.
Okay, yeah, but where's the decimal right now? Where's the decimal? Sorry, yeah. Where's
the very far right side?
So the very far right side, I would say that here's the decimal, right? 0.0. Okay, it doesn't say that, but you could imply it. So there's the decimal at the very end. Now I want to get this into scientific notation, which is typically one digit left on the left of the decimal, and then you could have a couple on the right. Okay, so I want to get the decimal all the way back to here. I want to get it back to here. Okay, so I know I'm going to want 1.25. Then your question has to be times 10 to the what goes in the exponent on the 10. That has to be your question. Okay, so how many times do I need to move that decimal to the left in order to end up right there? That's your question, right? So it's as easy as counting the bumps here, right? 1, 2, 3, 4, 5, 6, 7. Does anybody have any questions? Okay, it's typical to have one number on the left. I don't think you'd see this. I don't think you would see this. That's not allowed. Okay, it's one number on the left. And then whatever subsequent decimals, however precise you want to get after the decimal. Okay, but before it's just one unit, one number. Okay, does anybody have any questions? We'll do this one. So same thing here. You look at the number. That's a lot of zeros, so you don't want to type that in your calculator. So say, okay, I need the decimal to be right there. How do I move the decimal? Well, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Nobody said anything yet, and I'm curious as to whether or not anybody does say anything. Just let me finish this question. Which way did I move the decimal? To the right. So what has to go here? Positive what? How many did I count? It's okay. Raise your hand. Hazel?
For A, wouldn't it be 10 to the power of positive 7?
But why? I'm not disagreeing with you, but I didn't get it. Nobody said anything. That's fair. That's fair. I'm trying to teach you a lesson, though. I'm trying to teach you. Because this would be, if you were going to make a mistake with this, this would probably be the mistake you make. Colson?
Isn't A supposed to be to the power of 7 and B to the power of -11?
Okay. Does everybody agree? Well, let me ask you a question. Let me erase some of these bumps here. Which number is bigger than which? Elizabeth? A is bigger than B. So, it looks like if I were to try and reproduce the number in A, using the exponent that I have there, what's going to happen? Is A going to be a big number? It's going to be really small because I'm going to move my exponent the way I've written it is going to move to the left. That's not going to give me the original number back. It's going to give me the exact opposite. Does everybody see what I'm saying? This is almost like a check. Like you think back to like your linear stuff. If I were to like actually do this and convert it, this is telling me to move this 1.25. It's telling me to move the decimal left 7 times. 1, 2, 3, 4, 5, 6, 7. Is this the number that's in the question? We went the wrong way. So Colson and everybody else who's questioned it is correct. It needs to be positive 7. So that when I take 1.25 and I move that decimal 1, 2, 3, 4, 5, 6, 7, oh, would you look at that? I get the original question back. Be careful. I swear I know what I'm doing. That'd be the mistake. If people make a mistake, that's the mistake they're going to make. Okay? They get too confident and they go, I got this. And they don't think to check of whether or not their number actually is going to produce the original number in the question. Right? Does everybody see what I'm saying? So just be careful. Okay, that has to mean that this one is negative. So here's your rule. I'd say positive exponents represent large. Here, look. Here, I'll do something with large numbers. Negative exponents questions, comments, concerns? I'm going to go down to the other page there. I'll leave those other two for you to try. Just be careful. Okay. Or do we need to copy still? Are we good? All right, 1.2 times 10 to the 6. I always like writing. Here's what I want to do. I take 1.2, write it down like that, and then I go move it 6 to the right. This one is a lot easier because you don't have to worry about going the wrong direction. 1, 2, 3, 4, 5, 6. Boom. 1, 2, 3, 4, 5. There you go. What's that number? Well, 0, 0, 0. 0, 0, 2, 1.2 million. Is that enough? Can we try the rest? Why don't you take 5 minutes, try the rest? Okay, I have tons and tons for you to try today. So you don't make the mistake that I think you're going to make.